Hello guys, in this session, let's learn something about cloning. Okay, so that's the name of the session here, analog layouts, mastering layout cloning methodologies. So as an analog layout engineer, you will come across lots of scenarios wherein certain portion of your design of your circuit will be exactly similar. Okay, so layout design is all about quality and efficiency. Okay, your design should work on silicon, and at the same time, it should have proper quality. And as a layout engineer, you are expected to be more efficient you know so to deal with these things, yes, all the EDA vendors come up with lots of layout design techniques and options which will facilitate the layout engineers to ease up their work and fasten up the layout deliverables. So in scenarios like that, there are some options. Generally, as far as the layout engineer is concerned, generally they ask in interviews about, do you know about cloning? I mean, there are alternative ways of doing things much faster, but then sometimes this particular feature comes in handy. Okay, it really helps in analyzing the design and debugging things and all of that. So let's dig a little bit into this and try and understand what exactly is cloning and what are the things we can learn in cloning which will help you as a layout engineer. So in this session, we'll be talking about what exactly is cloning. Why do we need cloning? Cloning in the sense, say, for example, the generic terminology, if I have to say, you've got replicas, you can say, okay, and certain portion of your design, this and this are exactly similar. Okay, as far as the circuit design is concerned, just assume that this portion of your design and this portion of your design is exactly the same. Okay, then as a layout engineer, if at all you want to efficiently and quickly finish, okay, the layout, and if you need symmetry between two different modules, symmetry of routing, symmetry the way or in the way which you're making connections, right? If that has to be the same, and you want to fasten up your layout work and reduce your share of work, that's where you use these features called cloning. Say for example, if at all you've got a design which has got some circuits, some connections, which is exactly same as this portion, so you don't have to do the routing and placement and floor plan exactly the same for this. Don't do repetitive work. There are efficient options which the EDA vendors give you. Try to utilize that to reduce your share of work. Work smarter, in short. So that's where we call it as cloning. Cloning in the sense of copying, right? So that's where you utilize this feature called cloning to make your life easier. Okay. So where can we use cloning? That's what we have just spoken about. You can use cloning in scenarios wherein there are similar portions of circuit, wherein there you have to have, the routing has to be similar, the floor plan of the devices has to be similar to match the delays, to match the routes, the caps, everything. These are the scenarios wherein you can use this. Apart from that, if at all you want to avoid repetitive routing, okay, and constant, so there could be scenarios wherein you are editing at one place and other places it's getting edited, which will fasten up your work. So these kind of features will help you really very well while you're doing layouts. So what are we going to see in this session is we have taken lots of real-time test cases, and we are trying to show you that, okay, this is where you can utilize cloning. This is how you need to do cloning. Say we've taken a couple of test cases here because, rather than just talking and all, it's better we show you how exactly it's done. That will really help you. You can implement the same while you're actually working. So cloning using a schematic. Generally, we have seen, you might have seen lots of videos on the internet, cloning is done using layout views, but then no, there are multiple ways of doing it. You can do it using schematic also. So it's the schematic what you're referring to and then doing the layout. Okay, so that's where your thing comes into play. So you are utilizing the schematic design and then doing the layout. So if at all you see some similar structures in the schematic, you can very well utilize those. Okay, you can create clones out of it. We'll show you how to do it. Same thing if at all you want to generate cloning using the layout views. Okay, how to do it? We're talking about. So probably assume that you have already generated layout instances in your design. Okay, and using the layout instances, you want to generate clones. How to do it? We'll talk about that. So we are just trying to show you multiple ways of doing things because you never know how the design looks, how it is. So you need to have multiple tools, multiple techniques you need to learn to be able to do your job or make your life easy. Okay, we learn about that. And cloning hierarchical designs. So cloning, it's not just that you would be doing it at a very transistor level. No, it's not that way. You can do cloning at hierarchical design, which means what? If at all you've got a bunch of modules here, say for example, 1, 2, 3, and 4, just for the sake of explanation, if you've got that, okay, let me just take a copy of that. So what it means is like you can, if you observe in your schematic or in your block diagram, if the signal routing is exactly the same, the modules are similar, the signal nets are similar, you can very well create a clone of this portion of your design and this portion of your design. Okay, you are trying to create symmetrical routing, or we can also call it as it can very well be utilized in half cell concept. Okay, you can even call it as a half cell concept. Generally, whenever you've got similar portions of your design, you tend to route only this half portion, replicate it, and do it. But on the other side, you can create clones, and whatever routing and placement and floor plan you do in this section of your design will exactly be the same in this portion of your design. This helps you create symmetrical layouts, okay, which is very, very important when you're working with analog layouts. So it's not a must that it has to be used in analog only. No, this can be utilized in digital portions of your design wherein the routing has to be similar. The routing lengths of bits and signals and all of that, if it has to be similar, you can utilize these features even in digital designs also. It's about observation on how you look at do it. So routing using clones. So how you can do the routing using clones and without the clones. Okay. Now, if you get slowly familiar with cloning techniques, then yes, you can go for it. But there are alternative ways of doing things. Okay. Cloning is something which has come up recently, even if I have to say recently, a couple of maybe 8 to 10 years ago. But then, yes, still, not everybody utilizes cloning. Okay. Yes, it is a very efficient tool, but then not many of them are very familiar with cloning techniques. So we go with orthodox way of doing things, but then there are alternatives as well. Now, depending on what you want to do, how you want to utilize, what practices you want to follow, you can uh, stick on to that. But then here we are showing both the ways of how to do it. Okay, and then we come across, as and when we work with lower technology nodes, we come across lots of stacked devices. Generally, biasing circuits, current mirrors, and all of that use lots of stacked devices. Okay, which means what? About hundreds of devices are grouped together or tens of devices, and then they are used to do the current mirror and all of that. So in cases like that, how do you utilize this particular feature to reduce your share of work? You don't sit and flip each and every transistor to do your layout. No, you don't do that. When you've got tens of transistors, if at all you have to array them, share them together. No, you don't do that. Okay, you are wasting a lot of time. So that's where you utilize the stack devices, features, cloning and all, and then you do it. So that's where we talk about stack devices using cloning. Now, again, without using cloning as well, you can use a feature called synchronous copy. Probably it's an extension of your cloning. There is a slight difference between cloning and synchronous copy. Okay. What that is, cloning refers to the connectivity with your schematic. Whatever the connectivity information is shown in your schematic, that reflects on your device in your layout P cells or instances. Whereas when it comes to synchronous copy is layout specific. Okay, so whatever layout geometries you have drawn in your layout, you can group them and you can create a synchronous copy of it. And whatever edits you do here, these edits will be visible in this synchronous copy what you create. But there is no equivalent schematic to this. There is no equivalent schematic to synchronous copy what you have. So that's the main difference what you see between when you're using cloning or synchronous copy feature to do the layouts. So you can do mix and match. We've spoken about lots of other features like using what you call chaining features, using abutment features, all of this, trying to show you how quickly you can do this. So we'll be talking about all of this in this session. So Do stay connected with us on all of this through all of these platforms. You can stay connected with us on WhatsApp group or through email. Anyway, all the information is over here. You can watch the session on Semionics Academy, where this whole session is mentioned in detail. Thank you.